So today I want to give you some insights into the project Moby Dick, directly starting into the object of our interest. So imagine you walk along the supermarket and those open fridges. You might have multiple questions about your lunch, what to eat today, maybe some yogurt or so, and then you come along this cress tray. You might think about, do I like cress? Does it match the fish or so? That's all reasonable questions, but the guys from our project and their companies, they have different questions about this product. I brought some of those questions that we address in the project with me. One of them is, for example, how much recyclate can I use in order to produce this tray? It's made out of plastic, out of PET in our project, and still get the quality that I want to have. Another question is, how do I have to set the machines which are used along the life cycle, which I will show in the next slide. Also, if I want to use this recycled PET. Next one is coming or motivated by the more stricter getting laws, because the manufacturers have to provide information about the materials which have been used and about the additives they used in order to be recycled better at the end of the life cycle. Example is, how can I reduce the CO2 footprint along the whole life cycle of such a product? That's some of the questions that we address in Moby Dick. What I want to show you today is, first of all, the product life cycle, that you get some information how such a tray is actually manufactured and what we do in the project. Second one, the approach in the project. So what are the use cases? How do we gather data? Third one is the target situation. So if we could make a wish, what would be the ideal situation after this project? Fourth one, the internal motivation. It's not the first project that we do in Material Digital, so we also have some learnings out of the previous projects, which leads us directly to the domain agnostic architecture, because we try to develop a software which is actually domain agnostic and helps guys to work with knowledge graphs. Finally, I want to show a small demo video of the current state of the project. Let's start with the product lifecycle. It starts all with granulate. In this case, it's just small drops of PET. That's fresh, so we buy it in the project. It's about 20 tons or 15 tons. This goes to Reifenhäuser. Reifenhäuser is a machine manufacturer for producing foils. In the project, they will produce foils out of this granulate. Then those foils go to Wolf. Wolf is an SME, and they do the thermoforming. Out of this, we have lots of cress trays, because that's our demonstrator in the project. They go to Hochschule Aalen, which do plenty of material characterizations, for example, tensile tests, viscosity tests, or measuring the geometry of the trays, not only of the trays, but also for all other elements like the foils and the granulate. The trays then go to WeSort AI, which have a camera-based technology to sort different types of material. Then the PET trays again go to Polytech, which will do the recycling, so getting the waste, producing new granulate, which is called then recyclate, because it has already done one complete life cycle. In the project, we will do this whole cycle 3 times. And during those 3 product life cycles, we capture a lot of information for different aspects, like, for example, the parameters used for the machines, or the material characteristics, the energy consumption of the machines. And the task for us, Fraunhofer IGCV, is to organize all of this information into fair data using ontologies and some other techniques in order to provide answers for the use cases, which we will see later. The approach in the project and the current status. We started in September, and we are now at a quarter approximately of the whole project duration. So we still have plenty time to go, which is cool. What we did so far, or where we started, is every company was asked to fill out like a wish list and define their use cases or user stories. It's comparable to competency questions, but at least in my head, a competency question directly transforms to a SPARQL query. And for me, the user story is more than just a query because it involves more data manipulation techniques. So every company has at minimum 3 user stories. One of them, for example, is of Reifenhäuser, where the process engineers want to know how to set their foil extrusion machines in order to be able to manufacture or use recyclate, and they still want to get nice foils out of this process. Based on those 28 user stories, we thought about which data do we have to grab out of this life cycle. For this, we created a monster Excel file where we tried to gather all data points which we will have to save or capture. For example, one of them would be the density of the foil, or the density of the trace, or the tensile strength of the foil and the tray, or, for example, the energy consumption of the extrusion machines. So that's a huge Excel file, 600 different data points or data categories, which we want to capture. To do this, as I told you, we do 3 times the full cycle. Currently, we are in the first cycle, and we have the foils, which now are already at Wolf, and I think in 2 weeks or so they will produce the trays, and then we will go on. Target situation. We have now the user stories of the different companies. So the target is that at the end of the project, those guys at the different companies have an application X where they actually get answers for their problems. This can be a chatbot or something else, but that's the task. They want to have an application which helps answering their questions and providing answers for their user stories. What we have is we have different companies in the consortium which have different types of data and files which somewhere have to be placed. We now need to go from the left, so heterogeneous data sources, to the right, where we at Fraunhofer try to use fair data, so transforming all those heterogeneous stuff into fair data using ontologies. Then we want to do some analytics, that's building correlations, statistics, and further stuff in order to provide the information for this application X. We have some companies or institutes They need more or less, or they do also both. For example, Novicos, they do simulations, structural, so material simulations, but also process simulations. They need, on the one side, data. For example, they want to query what is the tensile strength of recycled PET. Then they do their simulations, and as an output, they somewhere put their results. For example, the simulation results, or TopQM systems, they do the CO2 calculations. That's the main or high-level objective. Guys having data and they want to have answers for their use cases with an application. The internal, I have the header here, it's always the same, meaning it's now the third project for me personally in Material Digital. And I noticed that I actually always do or did 2 times the same. The first project was ODAM. The domain there was additive manufacturing. The guys also had heterogeneous data sources. They wanted to know how can I set my machine parameters to have good parts. Second use case or project was hybrid digital. The domain was having steel and CFRP, so carbon fiber reinforced plastics. Also there you have different types of files and data sources, and you want to answer questions. What I did then is using a bunch of different tools, like for example Protégé to create the classes, then creating a bunch of Python scripts which read in the OL files, transform the different file formats, then having the mapping, so from the raw files to the classes, then lots of manual tweaking in different scripts. It always ended up in a solution. So in ODM, it was really small demonstrator. In hybrid digital, it looked already better, also the UI, but first of all, it worked. It worked out for these use cases, for these projects. The problem is, at the end, I'm pretty sure that at this state, this cannot be directly used in industrial use cases, because the whole code and architecture and also the general architecture in mind is always bound to a domain. For this, it's hard to reuse because everything is somehow mixed up, so modeling and extractions. And additionally, there are just missing aspects which are needed by industry, like user management. You need different roles, or you have different departments in your company, for example. And also, of course, just this whole workflow, so using Protégé and then Python scripts, this just worked out because I'm one single researcher who had time enough to deal with this stuff. But that's not realistic actually for industry, at least I think so. So that's the outcome, the critical outcome of the 2 projects. What also happened is, now of course we have a new technology with LLMs, which might help out for our project now in Moby Dick. And one big aspect is a Copilot. So as a tool for example, me as an engineer and not a software developer, to develop software or to create code which at least will be or should be better spaghetti code than my spaghetti code. That's the starting point for Moby Dick, which led us and me to the decision that we not want to start always from the beginning. Let's assume we are in Material Digital 15 or so and not always want to start again. Meaning we try to work out software or a demonstrator which allows to be used. It's just an approach to be used domain agnostic. Architecture, just the coarse one. We are still at an early stage in this project. I want to step through now. We call it OntoFlex. I need to check if this is actually available as a proper name. First module in this workflow must be data source management. So what I describe now is the target state. That's not what we already have on. First module must be data source management. So I want to be able to add and delete and manage different data sources. For example, adding Microsoft Azure Blob storages. We use them in Moby Dick, or Google Drive, or machine REST APIs, OPC UA, for example, with the objective to always keep in sync all files and data flows which come in there. That's the first task or module. Second one is class management. I want to have an editor integrated which allows me to manage my full class hierarchy. I want to add classes, delete access, delete classes. I want to add axioms and and labels, comments, everything which is needed there. With the critical aspect, this must be fully versioned and fully validated. So if somebody does a change, let's say a colleague in the department at this class structure, this must be clear, this was the colleague, and this must be validated either by another person or in the ontology super chief. This must be transparent so that it's not just one guy who works in Protégé or so. That's at least my my thoughts about this. Also, we have here this small icon of the friendly robot, which means we want to use agentic approaches here. You will see it also in the next steps to support users which are not familiar with the respective step. For example, they do not know which or where should I put a class, what's the appropriate superclass. Just that they get guided, because also here I think in industry you just cannot tell your colleague please download or read the 200 pages of BFO documentation. I think it's just too hard. Having the classes, we want to have modeling patterns. It's also something which I noticed when looking back. I always created classes, and then I had code which read in the file content and read in classes, and in the code itself the patterns have been hidden more or less. So for example, the code creates an instance of dog and creates an instance of name and creates between those two instances the relation has name. So dog instance has name instance. So the actual pattern that a dog has a name, I had not written down somewhere. I want to have this now. So also here, this must be fully versioned and fully validated, that those modeling patterns are transparent in the whole workflow. Currently, we are using defined classes here. So every pattern is actually an axiom or multiple axioms for classes. Currently, we are not at the point that we already did this actually modeling, but I plan here to, or in the last projects, we used PFO and CCO. In Moby Dick, I want, or at least I try to use the PMDCO, and I saw that there in the GitLab repo, there are those patterns already, and that's actually exactly that what I want. So in an ideal case, I just can import all patterns from the GitLab, GitHub, don't know, repo, transform it to define classes, and then use them. But we are still not at this point. Having those patterns, I want to be able to create actual advices, I call it recipes, which describe how to map information or data from a raw file to such a pattern. This has to be distinguished from the actual process of selecting different files and say, okay, yes, use this method to extract the information from file A to this pattern. Here we can also think about different possibilities. This might be column mapping, or also here using LLMs. And also here, I expect we need full versioning and validation mechanisms. If we have this, we come to the actual process of stating, okay, this recipe, so this advice how to extract info or map, or first extract then map information from a raw file to a pattern. At this step, you decide use file 1, 2, 3 with this recipe and extract the information to this pattern. Also, this must be fully versioned and validated. Having this, we come to entity resolution. So handling that two documents might talk about the same physical thing could be everything of reality. And in order to be able to do so, we need actually criteria which state if you have information A and B about an object or thing, you can ensure that both are the same. For example, for apples, you might set up the criterion. You can uniquely identify an apple by the color of the dot it has on its surface. So if you have two different documents and there are descriptions about an apple and both mention that his dot has the same color, then you might infer, either based on the raw content or in the knowledge graph later, that both are the same instance. Having this, we want to have rule management, meaning I want to bring in knowledge or information not based on files, but something which I just write down. One example in Moby-Dick will be the calculations for CO2, which might be, for example, CO2 is 5 times the power used of a machine plus 3. It's not that easy, just an example. So I want to write this rule down, and then it should be applied directly to the graph. So search all power instances of all machines, multiply it by 5 and add a 3, and add a new node. The CO2 of this process has been 10, for example. Also here, I want to have full versioning, full validation. After this, we have hopefully fair data, so classes, defined classes, and the instances or raw data mapped to it in form of instances. Having this, we need the actual analytics, which can be, for example, correlation engines. Here the objective is to get out, for example, the expression, the density of, or the recyclate fraction of the granulate affects the tensile strength of the tray in the life cycle. Just as an example, originally I thought or planned to use graph neural networks there. It just did some first approaches. It should work out, but you have a limited interpretability here. So currently I'm trying some different approaches to transform it first to a table and then do some statistical stuff, which hopefully works out. After this long way, we actually come to the querying. So this will be the part where users get their answers, hopefully. And here I plan or do a mixture between RAG. So all files are chunked, and so the agent can query the actual raw sources, and additionally he can query the actual graph. Which brings me to a question which I still have to answer. When we look at the whole chain from data source management to querying, that's much work. That's really much work and requires different competencies to be able to answer the question. So somehow in an industry context, there must be the point, and actually I think this must be also in such a software where it's estimated, okay, user, currently I cannot answer your question. You should do the hard work of going this long path. So create your class, create your patterns, do the recipes and stuff like this. So because I think you just should use the technology which answers your question, and this will not be always going the full chain. So somehow there must be a mechanism which helps out here, which I still have to think about it. Further overall aspects are, for example, the user management and data access restrictions, because you might have different departments with different users which are allowed to see files or not. You need an admin section to avoid actually the handling of different Python files and stuff. You just want to enter something and create a new user, or everything else you want to manage. Code architecture. Also here, the last approaches have been coded primarily by myself. So now we plan it to make it cleaner using Fast API and React and everything in Docker containers. And we need full provenance information along this whole chain, which means, or is actually captured by versioning. But you want to know, I got an answer, from what or where from did I get this answer? That's the target state of the project, and it has been pretty enhanced compared to the original project proposal because of the outcome of, for example, now Copilot and yeah, the analysis of the last projects. And yeah, we just a disclaimer, of course, we cannot guarantee, and it will be impossible that we come out with an perfect production ready software. That's just not realistic, but we want to keep this objective, the limit or the ceiling, maybe. Yeah. The current state of OntoFlex, I created a short video yesterday evening, so it's fully under development. So don't trust your eyes. Behind most of the, or many buttons, still the wind is blowing, and yeah, it's just a big task that we have here. Nonetheless, I want to show you the current status. It's about 7 minutes, I think, the video. It's a browser application. We have already reserved the domain, but it's still blank. because we are not at the point where we want to upload it due to the bad guys who might attack us. And also currently we still not see the point that it has already usage for our project partners, but it will come. You go to the OntoFlex page, you log in. In this case, it's with the admin. Then you come to the starting page where you see all the different functionalities which are more or less arranged along this workflow which I showed you. As an admin, you have the admin page where you can do admin stuff. Again, don't trust your eyes, it not works everything. But you can create, for example, users or delete them, reset the passwords. You can create new tenants. A tenant is a fully isolated software in itself, more or less. Let's assume we have two departments. The first department manufactures, for example, cups, and the second one watches. So they actually want to be totally separated. They have different data sources, different classes. In this case, you would just create two different tenants that's fully isolated, different users, no intersections. Here will be the part of access groups. There's no front-end implementation so far. In the background, it's backend, it's still Brittle also, where you then should be able to set which user is allowed to see which data or files, and then we have to wire it through the whole application. So filtering the raw files, but also on triple level, for example, filtering inside the Sparkle queries. Here we have the agent activities. So all agent activities are tracked. So just for debugging, you can set up LLM cost budgets, because LLMs cost something, vector store settings, unit management, and yeah, just other stuff. But that's not all implemented yet. But hopefully it will be at some time. At the top, you can switch between the tenants and what is next? Data sources. Here you can manage different data sources. As I told you, we use Azure Blob Storages, so we just can connect Azure Blob Storages, but if it's designed in a way that it is in the future possible to extend it to Google Drive, or for example, to RCycle API, which is a format or a consortium out of different companies in the polymer industry, and they have a consensus about different data formats to store information about packages, like, for example, additives. You click on Azure Blob Storage, then you add here the URL, so like the password to connect, which is hidden here so that you cannot get our sensitive data. And you click further, you give it a name. In this case, it's the blob storage of the Hochschule Aalen. Also here, the approach is every company has one isolated Azure Blob Storage, so they do not see the files of the other project partner. With this, we want to enforce that the users actually use later OntoFlex if they have any question about data. But of course, this makes pretty high pressure on us that OntoFlex actually works. So if we notice in the upcoming weeks or months, okay, it does not work, we are just too slow for it, then of course we open up the doors. But that's also a learning for us that in the last projects I developed always next or streamlined to the project, and most of the actual data transfer still happened using raw files or email. You enter the name, you can set the sync interval, and after this you can register it so it connects to it and keeps the files in sync. Now it's 2 containers connected. You see the files here and also the sync history. It's just testing here 2 files. We have the file browser. Still, we do not deal with any classes here, where you can just browse the raw files. For example, here it's a CSV, you can inspect it. What also happens is every file gets chunked and embedded and stored in a vector store. That's done in the background. Of course, as a user, you would not look at the chunks. That's debugging. The same for the other container. It's also with test data and for example, PDFs, they also just get chunked. What you can do then here in this file browser, you can search. Full text does not work, but semantic search now uses this vector store. So it embeds your query, sends it to the vector store and searches matching files. In this case, for metal, it finds this CSV because there is stuff, at least I think so, stuff like aluminum and steel in it. It's just a function which I think is nice to have, or I think I would want to have it. Next part, schema editor. So that's the class management part. It looks more or less like Protégé. At the left side, the taxonomy. At the right side, the class overview. And so also this is still brittle, many bugs, not perfectly working. If you want to do changes, you can start a new staging session, meaning at this point, every change that you do is captured. For example, if you add a class, if you rename an IRE, add an axiom, and after you did your changes, you have to do the reasoning to ensure that everything is consistent, and then it goes to the validation board. So this would be then a specific role. You are the validation guy for classes, and he can then he or she can decide then, yes, that's fine, or that's not fine. Going back, we have the identity module that's still wholly empty, at least in the front end. Back end, there is already some implementations and thoughts, but here would be the part where you define how to identify unique instances. It was the Apple example before. We have the recipes. Here the plan is, or the task flow, you select an example file, for example, a CSV. Then you select your patterns. As I told you, patterns are, at least I want to try this way, defined classes. So here you now patterns, you define classes. I just search for a random class here, which is partially appropriate. Also, this is still fully under development. You select the class, go on next. You have now at the left side the column headers, and on the right side the visualization of this pattern. In this case, it's act of screwing, which has as an input a laminate and I think a process profile torque. Now the task is you need to define how to fill those data property slots here. And possibilities. First one is just drag and drop. Second one, that's still brittle, should be Python. So you can, for example, define the torque is 5 times the column A, let's say. Also, you can use, that's the first example for an agent which supports the user. You can use an agent to do suggestions. So in the background, now the agent gets the pattern and the columns and some example data, and then does a proposal which one to use. So for example, here now the laminate ID is to the information bearing entity of the artifact ID, and the torque is added to the process profile chain. Another aspect is units. That's also a fully separate module, how to handle units. And yeah, I skipped this for now, but it's also own module where you have to define unit class and what are the specific unit instances then. And here now you select the instances, for example, that's Newton meter. Then you accept the proposals, go on next and say, okay, let's go to validation, which does not work currently. There was a bug, I already found it, but now it should appear here in the validation board. Finally, we can go to the, I call it Knowledge Graph Explorer. That's an agent-driven chatbot, which can do in the background the RAG, so retrieve information from the raw sources, but also can query from the graph. We still have no instance data currently in the Triple Store, but just to give you a feeling, you enter your question, it goes to the agent. The agent has different tools. For example, you can search the ontology classes based on embeddings. He finds now the class. Now he creates the Sparkle query to query instances of the class portion of metal in this case. He doesn't find something. He searches the subclasses of, he gets stuff. And then if he decides, okay, that's enough, he outputs the result, which is not fancy rendered so far. But also here, the plan is to have full transparency then. So to know which files have been used for generating this answer, or also which triples have been used to answer this. And I think here the demo ends. Summarized, in mobyDIG, we try out of the learnings to create demonstrator software which is domain agnostic and supports the whole workflow. And yeah, hopefully, or maybe now if you go through the supermarket and see a crash tray, you might think of ontologies, data, and information. Thank you.